Solve the following system of equations graphically. To solve a system of equations graphically, simply graph both equations and then determine the intersection point or points. For a system of equations with two quadratic equations, there are four possibilities. There could be two solutions corresponding to two intersection points, one solution corresponding to one intersection point, no solution if the graphs of the equations do not intersect at all, and an infinite number of solutions, which corresponds to the equations being the same graph but in a different form. These equations are given in the form y equals ax squared plus bx plus c. In order to graph them, I will convert them into vertex form. For the first one, y equals x squared minus 2x plus 2, in order to complete the square, I have to divide the term beside the x, negative 2, by 2, giving negative 1, and then square this, giving plus 1. Adding the 1 inside the brackets creates a perfect square trinomial. Because I've added 1, then outside the brackets, I have to subtract 1. This then gives our equation in vertex form of y equals x minus 1 all squared plus 1. This corresponds to a vertex at the point 1, 1, and an a value of 1, meaning the graph is congruent to y equals x squared. That means that from the vertex, as we move right or left by 1, we would move up 1. From the vertex, moving right or left by 2, we would move up by 4. For the second equation, in this case, to complete the square, we first have to factor the negative 3 out of the negative 3x squared minus 6x. This gives negative 3, and then in brackets, x squared plus 2x. We will leave the plus 2 outside the brackets. Again, in order to complete the square, we'll have to add 1 inside the brackets. However, we will not simply subtract 1 outside. This time, the 1 inside the brackets is multiplied by the negative 3 that we had factored out. This means that by adding 1 inside the brackets, we're actually subtracting 3. To compensate for this, we will then add 3 outside the brackets. This then gives our equation in vertex form, y equals negative 3 times x plus 1 all squared plus 5. This then corresponds to our vertex at the point negative 1, 5. The a value this time is negative 3. That means that from the vertex, as we move right or left by 1, we move down by 3. As we move right or left by 2 from the vertex, instead of going down by 4, we have to go down by 12. Drawing the graph, we can then see that these graphs intersect in 2 points. The first one at the point negative 1, 5, and the second one at the point 0, 2, corresponding to the two solutions of this system.